So let's practice with the Pure Maths 3 Algebra, and the subtopic inside the algebra is modulus functions. So just to show you why, because algebra itself is a long topic, so it has modulus functions, remainder factor theorem, long division, uh, we have partial fractions, and we have binomial expansion. So all of those things. So we will split this into different videos. So let's practice with the modulus function today. So this paper is October-November 2023 and paper variant 3.2. So October-November 23 variant 3.2, and this is question number 1. And sorry. Question number 1. Okay. Sketch the graph of y is equal to 4x minus 2. Now we know that this is going to be a V graph, but how and where the vertex comes, where it touches the x-axis, if it touches the x-axis, how to figure out that. Now, we know it's going to turn direction where it crosses the x-axis, so all we have to do is to figure out where 4x minus 2 goes less than 0. So when we try to solve this, this becomes 2 and this would go 1 over 2. That means less than 1 over 2, it will be in opposite function. So how we can actually rewrite the function? We can say this f of x or y, sorry, can be rewritten as a piecewise function 4x minus 2 when x is greater than equal to 1 over 2, and then it's negative of 4x minus 2 when x is less than 1 over 2. Okay, so when we draw this, somewhere we have 1 over 2 minus 1 over 2 minus 1, 0. For one of them, the vertex, or the y-intercept is minus 2, and for the other one it will be plus 2. It won't be exactly touching those, so let's see. So 4x minus 2, that means it's positive gradient, and minus 2 means that it's going to go like this, right? But it's not going to actually go there because 4x minus 2 only exists after 1 over 2. So we are just going to keep it this way. And the other one, negative, minus 4x minus 2, will be negative gradient, and that will be passing through positive 2 y-intercept. So this is our mod 4x minus 2 graph. Now solve the inequality 1 plus 3x less than 4x minus 2. Now we can do this two ways. We can do this with the help of the graph also that we have drawn, and we can also do this with the help of algebra also. So how we would do this graphically, if we sketch out 1 plus 3x, 1 means that it has the positive y-intercept 1, and 3x, that means it has lesser gradient than 4x minus 2. So still we would need at least one point of other intersection. So let's take y is equal to 0 for 1 minus 3x. So let's see, when 1 minus 3x, 1 plus 3x is equal to 0, that means we need to figure out what the x-axis intercept is. So that would be 3x is equal to minus 1, and x would be minus 1 over 3. So that's somewhere in between over here, somewhere between 0.25 and 0.5. And this is also crossing over here. So let's use orange just to show that this is going somewhat like this. And somewhere along the way, this green, when it's extended, it will somewhere, it will also intersect that, because the gradients are different, so that means it will definitely intersect. Now the 2 points of intersection we can see is one is over here and one somewhere far away when these two intersect. So we already know the exact uh, things. This is 2 minus 4x and this is 4x minus 2. So we can find out one way to do this is we can equate 1 plus 3x equals to 2 minus 4x and 1 plus 3x with 4x minus 2. Okay, so when we solve this, this becomes 7x equals to 2 minus 1, 1, and x would be 1 over 7. And the other one, 4 minus 3, that means just x, and 1 plus 2, 3. So x's would be equal to 3. So this would be 1 over 7, and the other one would be 3. Now, how else could we have done this? By simply taking the squaring method, which does not use this graphical visualization, but still that is also a very valid way of doing this. So what happens is that we take the square of both sides, and then we take the square on one side. You could like switch the places also, that doesn't really make that much of a difference. So oh sorry, my bad, I didn't finish it. So for less than, for the function being less than, for this orange function being less than the green function, we would have x less than 1 over 7, and after that also x greater than 3. So let's see whether we get the same thing in this way also or not. So since this is difference of squares, that can be written as 1 plus 3x plus 4x minus 2, and 1 plus 3x minus 4x plus 2, because minus minus. This simplifies to 7x minus 2, 1, minus 1. This goes like minus x plus 3 less than 0. So this is sort of like a quadratic equation, since one of these is negative. So this is a like this. This coefficient is negative, so the square of the coefficient of x squared would be negative. One root appears to be 1 over 7. The other appears to be 3. So when we want less than 0, we can see that this is when it is less than 1 over 7 and when it is greater than 3. So this part and this part. So yes, we are getting the same thing. Okay, so now let's move on to the next question. Okay, so this next one is also October, November 23, but this is variant 33, and this is question number 1 also. Okay, find the set of values of x satisfying the inequality mod 2x plus 1 minus 2 mod less than 0.5, giving your answer to three significant figures. Now, this may look a little bit scary, but all we have to do is to find a little bit of substitution for 2 raised to power x. So for example, if we say u is 2 raised to power x, then 2 raised to power x plus 1 can be split as 2 raised to power x times by 2 simple indices. So 2u basically. So when we rewrite this, this can become 2u minus 2 less than 0.5. Sorry, no. Sorry. This is 2u, sorry, not power, u. So now we solve this with any way we want. I think the easiest way would be to just to take the square. So 2u minus 2 squared less than 0.5 squared. We take the square on the other side. 2u minus 2 squared minus 0.5 whole squared less than 0. This is the difference of squares. So we plus them and multiply with the difference. 2u minus 2 plus 0.5 and multiplied by the difference less than 0. So this becomes 2u minus 1.5 minus 2 plus 0.5. The other one would be minus 2.5 less than 0. Now, since this is a quadratic equation, less than 0, one root critical value, so let's say critical values or roots appear to be 1u is 1.5 over 2, which is 3 over 2 times by 2, which is 3 over 4. The other one is 5 over 4 if we do the same thing. 2.5 divided by 2, that would be 5 over 4. So 3 by 4, 5 by 4. Since we want less than 0, so that would be this particular part in between them. So in between 3 over 4 and 5 over 4. Now u was 2 raised to power x. So it's 2 raised to power x that is in between 5 over 4 and 3 by 4. Now, the funny thing over here is that we can take ln across this entire double-sided inequality. So when, sorry, not ln, we can take log base 2 also over here, or any log over here. Ln could also be possible. So let's say if we want to take ln 3 over 4, x ln 2, ln 5 over 4, divided by ln 2 on all sides. So ln 3 minus ln 4 over ln 2 x, and ln 5 minus ln 4 divided by ln 2. Now, let's see, let's put this into the calculator. So ln 3 minus ln 4 divided by ln 2 minus 0.41. Since we want three significant figures, so 0.415. The other one would be ln 5 minus 4 divided by 2. So 0.322. So that's about it for this question. Simple. Now let's move on with the next question. Okay, so the next one is from May-June 23, variant 3.1, and this is question number 2. Okay, sketch the graph of y equals to 2x plus 3. Now, just like before, we need to figure out where it crosses the x-axis, and that would be the vertex. So we can just do 2x plus 3 equal to 0, or even less than 0, that would be fine also, because that's where we're actually making that negative function. So 2x would be less than 3 and x would be less than negative 3 over 2. So the function, which can be written now as a piecewise function, y, it remains 2x plus 3 when it is greater than or equal to negative 3 over 2, but it becomes negative 2x plus 3 when it is less than negative 3 over 2. So it's still V-shaped, but we now know the location. So slightly towards the left, 3, so 3 over here minus 3 over here, and 1, 2, sorry, let's go with minus 1 over 2. No, sorry, 3 over 2, sorry, 1.5. My bad. Let's keep it as 2, 1, and 2. 0, 0. Now, one function is 2x plus 3. So it's passing from the y-intercept 3. And the x-intercept, we just have to figure out very quickly. So 2x plus 3 equal to 0. 2x, no, sorry, that would be 3 over 2. Sorry, my bad, I forgot. So 3 and 3 over 2. That's about it. For the second one, it has the same magnitude of gradient, but negative. So technically, 1.5. So it would be the same distance. So 3 would be at 3.5. So this is 3. This would be 3.5. So same distance at 3. So and it would if passed through this. Oh no, sorry. Let's readjust that. Oh, sorry, my bad. Sorry. Then that would pass from 3 basically. Yes, sorry, my bad. So we don't actually have to take it to 3. We can just keep it over here because that is the vertex. Okay. This is the sketch. Y x, and this is the mod of 2. Sorry, mod of 2x plus 3. But for your convenience, this is 2x plus 3, and this is minus 2x minus 3. Now, solve the inequality 3x plus 8, 2x plus 3. So since we are short of time, let's go with the squaring method. 3x plus 8 whole squared, greater than 2x plus 3 squared. We take the square on one side, 3x plus 8 squared minus 2x plus 3 whole squared, greater than 0. Difference of squares, so 3x plus 8 plus 2x plus 3, and 3x plus 8 minus 2x minus 3 greater than 0. So 5x plus 11 and x plus 5 greater than 0. So this appears to be a quadratic inequality. Coefficient of x squared positive. So 1 is critical points, or roots are, one answer is minus 11 over 5 and the other is x is equal to negative 5. So negative 5 and negative 11 over 5. So since we want greater than 0, so that would be this area and this area. So when x is less than negative 5 and when x is greater than negative 11 over 5. Now, there's one little caveat over here. This is not over yet. If we sketch 3x plus 8 over here, 3x plus 8, let's figure out what the x-intercept would be. That is going to be minus 8 over 3, and minus 8 over 3 is 2.66, so somewhere over here, and 8 is very far above, so let's, keep it this way. Okay, now the thing to notice over here is that we are not getting 2 points of intersection because of the modulus part. The two solutions that we are getting are two possible solutions if the lines were complete, but the lines are not exactly complete. The minus 5 we would have gotten if this particular line was extended backwards, but this is not over there, so we have to see which one of them should be right. So there's no point of intersection over here. So there's only one point of intersection, and we can clearly see that this is only with the, I think that's 8 over 3 basically. No, sorry, that's whatever this point of intersection is. I think that's 11 over 5. Yes, 11 over 5. So that's that. There is no point of intersection at 5. So we have to only select this one. There's another way we could have done this also. Since they gave us the option of, since they asked us to make the graph, another way also exists to solve this. So we know if we just gently sketch it that when we equate, there's only like two possible solutions, like at most, right? So either 2x plus 3 will somewhere meet 3x plus 8, and minus 2x minus 3 will meet 3x plus 8 somewhere. However, 2x plus 3 exists after 3 over 2. And minus 2x minus 3 exists before negative 3 over 2. So if we solve them and see the intersection, maybe we'll get the answer more clearly. So when we solve the equation, we will have 3 minus 2x and 3 minus 8 minus 5. Intersection greater than negative 3 over 2. So there is no x is equal to negative 5 and x greater than negative 3 over 2. That does not exist. There's no intersection in that. So that's why we discard that. If we see this, we will get 5x is equal to minus 8 minus 3 minus 11. That leads to minus 11 over 5. And is that less than negative 3 over 2? Yes, that is less than 3 over 2. Okay, so we will only select the x is equal to negative 11 over 5. So if they're asking us to make the graph, so it's very important that we, visualize this on the graph also, what solutions make sense, what doesn't. If, like in the previous question, they did not give us any, they did not ask us to make any graph whatsoever, so we can simply use the squaring method. And we will get the right answer anyway. But if we're asked to sketch the graph, it's better to be sure about the answer. All right, let's move on. Okay, so the next question is from May, June 2023 also, but that is 3-2. So May, June 23, paper 3-2, and question number 1. And as we see, they're not asking us to make any graph whatsoever, so we can use the squaring method over here. So there's no, we don't need to go for that. So that becomes 5x minus 3 whole squared less than 2 becomes 4 and 3x, sorry, we can multiply the 2 inside, that would become 6x minus 14 whole squared. Now, since this is difference of squares, since this looks like a squared minus b squared, which expands, which can be factorized as a plus b, a minus b, we can rewrite it as 5x minus 3 plus 6x minus 14, and 5x minus 3 minus 6x plus 14 less than 0. So 11x minus 3 minus 14, that is minus 17, minus x minus 3 plus 14 is 11, less than 0. When we multiply 11x with minus x, that becomes the coefficient of x squared negative. So we have this kind of quadratic equation over here. So one of them is minus 11, and the other one is 17 over 11. No, sorry, x is equal to 11. Sorry. X is equal to 11. And 17 over 11. So since we want the area before that, less than that, so this area. So x less than 17 over 11 and x greater than 11. And that's our answer. Okay, so let's move on. So that's it for the 2023 papers. Hopefully next time we will tackle the other subtopics from algebra. Next video will be on long division, remainder theorem, and factor theorem. Okay, so see you. Bye-bye.